Hey all dear students, let's see this very good question of geometrical optics from IIT-JEE 1997. The question states a thin equiconvex lens of glass of refractor index mu is equal to 3/2 and focal length 0.3 meter in air is sealed into an opening at one end of a tank filled with water whose refractor index is 4/3. On the opposite side of a lens, a mirror is placed inside the tank on the tank wall perpendicular to the lens axis as shown. The separation between the lens and the mirror is 0.8 meter. A small object is placed outside the tank in front of the lens at a distance 0.9 meter from the lens along its axis. Find the position relative to the lens of the image of the object formed by the system. The information according to information that is given, this lens has a refractor index mu is equal to 3/2. This is embedded into a tank. As we can see that inside the tank there is a water has a refractor index 4/3, and then on this side of the tank there is a plane mirror. So lot of events will be there. So suppose for the image formation, what will happen, the ray will go from object and this fall on, suppose this is a surface S1 of the lens, this is surface S2 of the lens. So first ray will fall on the surface S1, a refraction will take place. So whatever will be image of this event will be the object for the next event. Now there will be refraction at S2, and then there will be reflection at M mirror, and then there will be refraction at S2 again, and then there will be final refraction at S1. So overall there will be 5 events. After these 5 events, final image will be formed. And remember, we cannot directly use the lens as a one system because we do not have a formula. We can derive the formula, but normally we do not have the ready-made formula for the focal length of the lens when the medium on both sides are the same. So medium on this side of the lens is air, and medium on this side of the lens is water. So I cannot use directly the lens formula. So what we will do, we'll do the refraction at a spherical surface formula, and for that we need to have the radius of curvature of the two surfaces of that lens, and because it is a equiconvex lens, so both radii will be same. To find that radius, we'll use the lens formula. In air, it is given that 1 upon f, we know that 1 upon f is equal to mu relative minus 1 for a equiconvex lens into 2 by r, where r is the ROC. And now this lens is placed in air. Given that the focal length in air is 30 centimeters, so there is a 1 upon 30, and material of lens has a refractor index 3/2, so mu relative is 3/2 only because outside is air, into 2 by r. So that will be just 1 by r. So from here we have got ROC is equal to 30 centimeter. Now we can start applying the refraction formula and then reflection formula. So a lot of things have to be done. So let's go ahead. So this is S1, S2, and this is mirror. Refractor index of lens is 3/2. Refractor index of water is 4/3. Here there is air, and this is an object. So first event is refraction at S1. Refraction at S1, this is the first event. For this event, the ray goes from air and goes to lens, mean this is a mu r is 3/2, mu I is 1. So apply the refraction formula at the spherical surface. So we'll write 3 by, and before that let's try to understand two things. Suppose for the event refraction at S1, the image is say I1, and for the refraction at S2, this image will act as an object, and for that refraction, suppose image is I2. This I2 can be on the right side of him or can be on the left side of him. I have just written this way. If it is on the right side, I will correct that. And for both these events, refraction at S1 and refraction at S2, our origin is the optical center of the lens because this is a thin lens. So And suppose the x coordinate of I1 and I2 are V1 and V2. So now for event 1, which is refraction at S1, so we'll write 3 by 2, which is mu r by V1 minus mu I is 1, and object is here at a minus 0.9 meter or minus 90 centimeter position. U is minus 90, and then mu r minus mu I. And for this first event, the COC is on the right side. ROC was 30 centimeter, so plus 30 centimeter. That is first equation. Let it be like this only. And then refraction at S2. For the refraction at S2, this I1 will be object and I2 will be image. And the ray will go like this. So mu I will be 3 by 2, mu r will be 4 by 3. So again writing that equation. So 4 by 3 mu r divided by V, that will be V2 minus mu I is 3 by 2 divided by U, which is V1, and then 4 by 3 minus 3 by 2 divided by R. And for the surface S2, the center of curvature is on the left side, ROC is 30, so R will be minus 30. So just add these two equations, 1 and 2. So if we add these two equations, 3 by 2 V1, 3 by 2 V1 will get cancelled. So we will get 4 by 3 V2 plus 1 by 90, and here I can take 30 LCM. From equation 1, 3 by 2 minus 1 is 1 by 2, and just because there is a minus in the denominator equation 2, so I will just invert that. So that will be 3 by 2 and minus 4 by 3. So this is 4 by 3 V2 plus 1 by 90, and this is 30. 1 by 2 plus 3 by 2 is 2. 2 minus 4 by 3, that is a 6, minus 4 by 3, that is 2 by 3. So that will be 2 by 90. So now my V2 will be 4 by 3 V2 will be 1 by 90. Oh, right, 4 by 3 V2 is equal to 1 by 90. So it means V2 will be how much? 120 centimeter. So now I will correct in the next diagram. In the next diagram, what I can say that this was S1, this was S2. O, first refraction here taken place, second refraction taken place. After second refraction, the image formed is V2 120 centimeter. So 120 centimeter mean from here 120 centimeter like this. This is a 120 centimeter. That is actually V2, or that is I2. So this image will be object for the plane mirror. So this is 80 centimeter, 120 centimeter mean this will be 40 centimeter. So I2 will serve as a virtual object for the plane mirror. So its image will be I3, which will be 40 centimeter here. Now the same thing happen on that opposite side. And if this is 40 centimeter, so that will be 40 centimeter. Now, once again, we have covered so far 3 events: refraction at S1, refraction at S2, reflection at M. Now, the 2 more events, now refraction at S2, and the positive direction will be like this: refraction at S2. For this event, this is mu I, this is mu r, ray is going from water to air. So, once again, 1 upon, same way, let me one more thing I just want to write. For the refraction at S2, suppose the image is I4, and that is its coordinate is V1 dash. And for the last event, the refraction at S1, the image is say I5. It could be on that side also, and its coordinates is say V2 dash. So for refraction at S2, mu r by V, mu r, the ray is going from water to lens. So mu r would be 3 by 2 by v1 dash minus 4 by 3. And this I3 was the object, and the left side direction is positive direction, so u is equal to minus 40 is equal to 3 by 2 minus 4 by 3 divided by r. For the surface S2, now the positive direction is towards left, and so COC is on the left side only, so r will be plus 30. Now this is, let me say, my third equation. And then the last event, refraction at S1. For this event, now the ray goes from this lens to air. So this is 3 by 2 is a mu I and 1 is mu r. So 1 upon the last image coordinate is a v2 dash minus 3 by 2 v1 dash is equal to 1 minus 3 by 2 divided by r. For this thing, r will be minus 30. And then add this equation 3 and 4. So adding these two equations, once again 3 by 2 v1 dash minus 3 by v1 2 dash will add up to 0. So what I will get, minus 1 by v2 dash, which is the x coordinate of the final image, plus this thing will be how much, 1 by 30, plus 1 by 30, and from the RHS I will take 30 LCM. So here 3 by 2 minus 4 by 3, and this is minus, so I will just change the sign of the numerator, that will be 3 by 2 minus 1. So 1 by v2 dash plus 1 by 30, here 30, 3 by 2 plus 3 by 2 is 3, 3 minus 1 is 2, 2 minus 4 by 3. So this will be 2 by 3 again. So that will be how much, 2 by 90. 2 by 6 minus 4 is, yes, 2 by 90. So now let me go to the next page. So 1 by v2 dash we obtained is equal to 2 by 90 minus 1 by 30, minus 1 by 30, that is 90 take LCM, so 2 minus 3, so that is a minus 1 by 90. So v2 dash, that is the position of the final image, is a minus 90 centimeter. For the last event, this was the origin, and this was my positive direction, this is object, and the image coordinate is minus 90 centimeters. So minus 90 means the final image will be to the left of this lens, and that is the final image, and I had named final image as I5 because this was the fifth event, and this is at a distance 90 centimeter to the right of the lens, and that is our answer. So final image is at a distance 90 centimeter to the right of the lens. Thank you.